Hey guys, what's up? It's Eric with Advanced Level Automotive, coming to you with another video. Today I got this 2015, it's a Jeep Renegade. I'll show you. 2015 Jeep Renegade. This is a 4x4 if it matters. And it has the 2.4 liter Multiair engine. I'm not sure what Multiair means, but anyway, this vehicle came in with a concern for the cooling fan. Customer actually purchased a cooling fan because she was pretty certain that the cooling fan was bad. I'm not really sure how she came to that conclusion. She said that she checked the relay and the fuse and came to the conclusion that the fan was bad, so she had a mobile mechanic come out to replace the fan. And then I guess somewhere in the middle of that or I guess before removing the fan, the mechanic tried to remove the oxygen sensor, or the front air fuel ratio sensor, I suppose in order to make room for the fan to come out. And in doing that, as he was trying to remove the oxygen sensor started to pull the threads out of the exhaust manifold, and at that point I guess he stopped and then bailed out on her. So she brought the vehicle here, recommended by a friend, and we were able to repair the threads in the exhaust manifold and put a new sensor on there because that sensor had no more threads on it. So we got the new sensor in there, and she had a new cooling fan, so we went ahead and installed it for her by request. But of course, after replacing the cooling fan, the problem still continued to happen, and she's still getting the same check engine light with the same code. So let's go ahead and let me show you what codes we got. We plug in my little scan tool. All right, so over here I got my little scan tool hooked up, got my little Autel Autolink. Just something to do a real quick code check. I'm gonna go ahead and put the key in the ignition, turn the ignition on, and let me turn the radio off. And let's go ahead and select OBD2. Let's check for codes. Two codes found. Read codes. And the first code we have is this P0481 fan 2 control circuit. And the second code is an intake air temperature sensor circuit high. So my first thought with this code is that somebody must have disconnected the intake air temperature sensor, but I've already checked and it's still plugged in. So I assumed that maybe the code was set during an attempted repair. I went ahead and cleared the code, but the code still comes back almost immediately. So this code, I don't believe it's related to the fan control code, but I think this is a separate problem. So let's go ahead and concentrate on the P0481 first and see if we can figure out what's going on with that. All right guys, so we're over here at the computer in my office, and I've got all data pulled up. And as you can see, we have the code description for P0481 cooling fan 2 control circuit open. And what we're going to do is we're going to take a look at the code description. We're going to get a little more familiar with the system, how the system works, and how this code gets set. So if we scroll down, we'll see some set conditions here. It says an open or shorted circuit is detected in the radiator fan relay control circuit. That's important information. If we scroll down here, it gives us a list of possible causes. It says that the radiator fan relay control circuit shorted to battery voltage. It says control circuit could be open. It could be shorted to ground. It could be a bad fan relay. It says it could also be a problem in the power distribution center or a problem with the powertrain control module. So there is quite a few different possibilities for how this code could get set. So let's go ahead and take a look at the wiring diagram, and let's get a little bit more familiarized with the system and how it works. So I'm going to pull it up over here. Let me move it over. All right, so hopefully you guys can see that. Now looking at this wiring diagram, it's a pretty simple circuit. If we look at the different components, you'll see that down here we have the radiator fan module. This is going to be the cooling fans and the module. It's all one integrated unit. And if you look over here, we have the powertrain control module, which is the engine computer. If you look up here, we have power distribution center, and over here we have another power distribution center. So there's two different fuse boxes that house both the fan relays. There's a relay for a low speed over here and a relay for a high speed over here. Now if you look over here, you'll also notice that we have a resistor for the radiator fan. Now the way the system works is it's pretty simple. There's two different speeds, a high and a low, and the way this fan is controlled is it's completely directly controlled by the engine computer. And the way the engine computer does that is by controlling the control side of either the low speed relay or the high speed relay. Now, if we take a look at the low speed function, you'll see that right here at the PCM, it says radiator fan control low. This is how the PCM is going to control the low side. And over here it says radiator fan control high. This is how it's going to control the high speed. So if we look over here, you'll see we have the battery, and the battery is going to supply power through the 60 amp fuse, which is fuse 6. It's going to supply power through this fuse, and that power is going to get spliced over here, and you'll see it gets spliced to these two different wires here, but these two different wires both go to the same relay. If you follow this power goes up to the switching side of the relay. And if you follow this power over here, you'll see that it goes over to the control side of the relay. So if you follow this, power is going to go over here through the coil winding of the control side of the relay. It's going to come out over here, and it's going to go down to the engine computer. And the way this works is whenever the engine computer wants to activate the low speed of the fan, it's going to ground this circuit here. When it grounds this circuit, it's going to energize the magnetic coil inside of this relay, which is going to close this switch. And when this switch is closed, the power that comes from here is going to go through the relay, and it's going to go through this white wire, and it's going to go through this resistor here. Now this is really important because this right here is what makes this the low speed setting. Without this resistor, it would just be a high speed. So this resistor is important in causing a voltage drop across this resistor in order to lower the speed of the fan. So again, when this switch closes, power is going to flow through the relay. It's going to flow through the resistor. There's going to be a voltage drop, and if you see, the power goes over here, and it's going to go to the radiator fan. And of course, this radiator fan has an external ground right here, and that's how this cooling fan gets powered. Now, likewise, on the high speed, if you look over here, that fan high speed control circuit, if you follow the battery power over here, it's going to go through this fuse 7, which is a 40 amp fuse. And if you see, this power is going to get fed to the control side and also to the switching side. So if we follow it on the control side, it's going to go through the coil winding of the relay. It's going to come out of the power distribution box. It's going to go straight to the engine computer. And whenever the engine computer wants to activate the high side or the high speed for the fan, it's going to ground this circuit. Whenever it grounds the circuit, that's going to energize the coil, that's going to magnetize it, and that's going to close this switch. When this switch closes, power from this fuse flows through the relay, and it's going to come out through this wire, and it's going to go directly to the cooling fan. So that's going to be an unrestricted full system voltage right here, because there is no resistor to drop the voltage. So that's going to be the high speed for the fans. Hopefully you guys are following along. Now, as far as the code that we're getting, the way this code gets set is one of two things. If you look down here at these two control wires at the PCM is actually watching for a voltage here and here. As soon as you turn the ignition on, there should be a power that comes from the battery through this relay here that reaches this pin here. Likewise, as soon as you turn the key on, there should be a power that flows from the battery through this fuse, through this relay here, and it should reach the PCM here. So with the key on, the computer is monitoring for a voltage here and also here. So the problem comes when you turn the key on and the computer does not see power here or here. Now there's a different number of reasons why that could happen. Like the code description said, you could have an open in the circuit, you could have a short to ground in the circuit, you could have a problem in the wiring, you could have a problem with the relay. If one of these relays is bad, that could be a problem too. But I think one of the first things that we need to do is simply check these fuses. And the reason I say that is because it is possible that her original fan, remember, we replaced her fan. She brought it to us because she purchased a fan. She wanted us to replace it for her. and we did replace it for her, but the fan still wasn't working and it kept popping up with the same code. So it could be that the fan originally was shorted, which caused the fuse to blow. And whenever we replaced the fan, we still weren't going to get any power to it because we needed to replace the fuse. So that's probably the first thing we need to do is check the fuses. Now there's two main fuses here that we should be checking. Fuse number 6, which is a 60 amp fuse, and fuse number 7, which is a 40 amp fuse. Now, according to the code description, it says cooling fan control circuit 2. I'm not sure if 2 is considered the high or the low. I mean, to be honest with you, it doesn't tell us in the code description whether it's for the high or the low speed. So I'm not really sure if it's missing a voltage here or if it's missing a voltage here. So we just need to go under the hood. We need to locate this power distribution center, and we need to check both of these fuses. Fuse box is located over here. And there was a little tab down there that if you just turn it, you're able to pop or slide this cover up. And if you look at the cover, you can see fuse number 7 right there and fuse number 2 right there. So let's go ahead and check fuse 7 and fuse number 2. We'll go ahead and connect my power probe to the positive and negative terminals. All right, my power probe on. If I touch it to a power, you see it comes on. And let's look down here. It's not easy to get to. Let me shine the light down in there. All right, so I'm just going to kind of go down the row here. We'll start with this over here. You hear it when I touch it, that means it's got power. So we touch both sides, we got power on both sides. That's a good fuse. Check that one. That fuse is good. Getting a little out of focus here. Let me focus you back in. All right, we're gonna touch this one. That's a good fuse. That's a good fuse. That's a good fuse. Let me double check that one. It looks like we're not getting any power on this side of this 50 amp fuse, which actually is fuse number 7. So fuse number 7, let me show you that again. I'm going to touch one side of the fuse. You hear that? I'm going to touch the other side, and there is no power on that side of the fuse. So this fuse is definitely burned. I'm going to go ahead and pull it out. All right, so I got some pliers here. I'm going to go ahead and pull this fuse out. If I can get a grip of it. There we go. And oh yeah, definitely that fuse is blown. You can see how it separates in the center. This is going to need a new 50 amp maxi fuse, so I'm going to go ahead and order that, get the fuse, get a new fuse put in there, and that should solve our problem with the P0481. So let's go ahead and move on to the intake air temperature sensor. As you can see over here, it is still plugged in. I'm going to unplug it. Look inside the connector. The connector itself looks okay. The pins inside the sensor. Pins look nice and straight. So this air intake temperature sensor looks to be okay. Let's go ahead and grab the graphing meter and let's back probe these pins here. Alright guys, so moving on to the air intake temperature sensor. If we look at the wiring diagram, this is a pretty simple circuit. I mean, if you know anything about these types of sensors, they're called negative temperature coefficient sensors, and these sensors change their resistance to ground depending on the temperature that they're exposed to. So it's a pretty much a simple 2-wire design. And if you look over here, we have the intake air temperature sensor, and you'll see that we have 2 wires. One is the signal wire, and then the other one is the ground. So the way this works is the PCM is going to send out a reference voltage on the signal wire, and then depending on the temperature of the sensor, which it's reading the intake air temperature, its resistance to ground is going to change. Now, if you look at this diagram, It may look a little bit confusing because if you look over here, we have the engine coolant temperature sensor. Now, just looking at it without thinking too much into it, you would almost think that the power would come through here and then come out through here, and then this is the ground, but that's not the way this works. If you look closely, this is the ECT signal. This is not the ground for the intake air temperature sensor. The way this works is that the engine computer is going to send out a reference voltage to the engine coolant temperature sensor, and then of course this is going to be the ground. Now if you look over here, there's a splice. So the ground for the intake air temperature and for the engine coolant temperature both meet at the splice, and if you look over here, you follow it over, it's spliced into the same ground for the oil temperature sensor. So if you look right here, this is the oil temperature sensor ground, and this splice right here, if you follow it up, you'll see that it goes back to the computer and it says sensor ground. So it's just drawn up a little bit confusingly, but just don't let it confuse you. Look over here, you'll see again the reference voltage for the intake air temperature is going to be sent by the PCM. It's going to come out on this wire here, this blue wire, and then you'll see the sensor ground is going to be here, and the sensor ground is actually shared with two other sensors. Again, we have the engine coolant temperature sensor, and then we have the oil temperature sensor. They're both grounded here at pin 34 at the engine computer. So that's pretty much how the circuit works. Let's go ahead and take a look at it. All right, so we're back under the hood. I'm gonna go ahead and back probe the blue wire, which is the reference signal that comes from the computer to the intake air temperature sensor circuit. And the ignition key is on. I'm gonna go ahead and use the power probe. Let's go ahead and touch this. Sorry about the glare on the screen. I'm gonna try to shade the sun here. I'm gonna go ahead and stick the lead of my meter in there. And we have 4.8 volts. So we know that the reference voltage is getting from the computer to the sensor. Let's go ahead and check the other side, which is the brown and white wire. That should be the sensor ground. And if you look at my power probe, my meter, it says 4.5 volts. So this is definitely a problem with the sensor ground. I'm gonna go ahead and disconnect this. I just want to check it disconnected because my meter, whenever it touches the ground, it should light up green and ding just like that. So I'm gonna touch it again, and we have nothing. So this is definitely a problem with the sensor ground. Now if you recall on the wiring diagram, this sensor ground is shared with the engine coolant temperature sensor and the oil temperature sensor, and we don't have codes for either one of those two sensors. So more than likely there's a problem somewhere between the ground wire here and wherever the splice is located. So let's see if we can trace that down. All right, so before I do that, I just want to do a real quick check on the engine coolant temperature sensor. So I'm going to go to live data, and I just want to check to see what the sensor is reading. Complete data set. And let's scroll down till we see right there, engine coolant temperature. So you can see it's 75 degrees. This car sat overnight and the engine has not been started yet. So this temperature looks correct, about 75 degrees, which is actually the outside temperature today. So yeah, looks like the engine coolant temperature is reading properly. I didn't see a data PID for the oil temperature, but if you look, we do have a data PID for the intake air temperature, and it's saying -40, and that's because the circuit is open. It's just going to read a default number here. All right, so we're back in the office again, and what I wanted to check to see is the splice number, so we can identify where the splice is at. S1070. So let's locate S1070. All right, so I found a picture that shows you where splice S1070 is located. And if you look here, there's a picture of it, and it's somewhere in the engine harness right here. So if you follow, this is where the intake air temperature sensor is. The harness follows down and goes into main harness right here, and the splice should be located somewhere right here. So let's go ahead and open that up and see if we can locate that splice. All right, so we're back under the hood. Let me show you what I found when I was trying to look for the splice. So according to the diagram, the splice is supposed to be somewhere in this area, I went ahead and opened up the wiring harness, but what I found that I didn't like was that the integrity of the wires were pretty compromised. So, I mean, you can see as soon as I pulled on this wire, it actually just came apart. That should not happen. I will say that this harness is located right on top of the engine, and there is a cover that goes here. So I think heat is definitely a factor as to why the integrity of the wiring is compromised here. But let me show you what happened when I went to tug on this harness right here, and I didn't tug on it very hard at all. I was simply pulling the electrical tape off of here and trying to move this harness, and this actually broke clean off of the connector where the IAT sensor is, as you can see. So that leaves the question is, was the problem in the splice or was the problem right at the connector? So to answer that, what I'm going to do is I'm going to use piercing tool so I can pierce this wire right here, and then I'm going to use my power probe to check ground. So if I touch the battery ground, you see it lights up and it dings. So I'm going to touch it, and as you can see, we have a good ground. So what that tells us is that the problem is actually not in the splice. The problem was directly at the wiring right at the connector here. I'm going to open up this connector, pull the terminals out, and I'm going to see if I can repair this. If I can't repair this connector, then we're just going to have to replace it. But this is something that I don't like seeing, because this is just kind of a precursor to what may be more problems in the future. So I'm going to fix this wiring here, and I'm going to fix this, and we're going to get it all back together. Alright, so I went ahead and repaired the wiring in here, and I actually had some extra terminals in a terminal repair kit that I had, so I was able to put some new terminals on this connector. So that's connected. We also got the 50 amp maxi fuse installed. So we got the new maxi fuse installed in there. So I'm going to go ahead and clear the codes, and we're going to see if they come back. So I'm going to go get my little scan tool here. I'm going to turn the ignition on. Key in the ignition there. Let's go ahead and check the scan tool here. See if I can get that to focus in there. There we go. Alright, so I'm going to go to read codes. Well, let's erase codes first. I'm going to go ahead and erase the codes. Yes. There we go. Erase done. And what I'm going to do is go ahead and cycle the key off and then back on. And we'll double check to see if those codes are back. Let's go to read codes. Stored codes. No codes found. Let's go to pending codes. No pending codes found. So let's go ahead and go to live data and see if we have a reading for the intake air temperature sensor. There we go. Complete data set. And there we go. Intake air temperature reading 98 degrees. So that sounds about right. I'm going to go ahead and start this thing up. Alright, so we're up and running. Check engine light is gone. And it looks like that's a fix. Anyways, guys, thank you for watching the video. I hope you found it useful. I hope you found it informational. I mean, I know the fix was pretty simple, but really what I wanted to do with the video was just kind of go over the system description and how it works and how it can be applied to pretty much any other vehicle that's out there. Also, understanding the system description for this vehicle kind of helps you guys build experience. And what I mean by that is, you might have one of these vehicles roll into your shop, and even though you've probably never worked on one before, you already know how it works because, you're like, hey, I remember I watched that video. We went over how the system works. So that's kind of what I'm trying to do with these videos, is help you guys build experience without actually having to build experience. It's kind of accelerator to experience, if you will. Anyways, like I said, I hope you enjoyed the video. If you did, please make sure to give it a thumbs up. If you haven't done so already, please subscribe to the channel. Make sure you hit that notification bell, and I hope to see you guys in the next one. Thanks.